One very time-consuming task during iOS development is testing that your UI works as expected. One way of speeding up this process is to write automated UI tests. In this tutorial, I'm showing you how to use XCUITest, which is a framework built into Xcode. In this tutorial, I will use this demo project where I will test if these items here are displayed, that I correctly remove these items, that when I press on this add item button, this sheet appears, I can add a new item, press add, and then this appears here. For these tests, there's a couple of problems that I also will try to address. UI tests are really slow. They can be flaky and brittle, sometimes failing in the future when you continuously work on your project on new features, which then causes your test to fail and give you false alarms. We'll try to prevent this so you can write tests that you will still find useful and will continuously run for the next months and years. You can find a link to this demo project in the description box. I already used this for an earlier tutorial where I wrote unit tests for this view model. This is a rather simple app where I have a list of items and then two functions for delete last item and add a new item. This I'm going to use in the content view, where we show the view model's item in the scroll view. I have here two buttons. One is calling delete last item function. The other button opens this sheet, this new item view, where I again pass this function to the view model to add this item. Now in this project, I already have UI tests included. If you don't have this, you can go under File, New, Target, and then add a UI testing bundle to this project. Now per default, Xcode will give you these two files with some predefined functions. Here you see I have one test example function where I launch XCUI application. This is then running your application in the simulator like a real app would do. Then we launch this app and afterwards interact with this app. Other things you can do with XCUITest is measuring performance. For example, they're measuring the launch performance, so you want your app to launch really fast so the user directly sees something. This you can also use, for example, if you want to make sure that a list in your app is scrolling smoothly. I have another tutorial where I test the performance of SwiftUI and see different implementations, so you can have a look at that. Today we are not going to do this, we're just trying to go through user flows. Now this predefined function, you see here these diamonds. These UI tests work with XCTests, so we see also again these XCTAssert functions. Now in order to write these, you tap inside one of these functions, and then down here you have this small record button, which I start. The application now will launch in the simulator for this testing, and we can start recording. This is just a quick start way of writing less code. Then I say remove last. You see when I tap here, the last element actually disappeared, my app's functionality, and also this code appeared in my editor. Sometimes it doesn't work, so then you need to relaunch it. You can also tap on this, and you see I get these static texts. Then I just press here on the stop button, so we can have a look at the generated code. So first of all, it regenerated these app code. It looks like it changed it to app activate. Let's just use this. And now I start this test by clicking on this diamond. This will then launch a new simulator. And you see it actually removed these items. You also see I have a different target for this. It's item app UI test, which is the name of this target here. So these are two different app instances. Now the whole test took 5 seconds, which has passed. And you see here this green diamond. Now let's have a look at the generated code. When I tap on these elements, you interact in code with this app instance, which works with queries. In this case, it's looking for a button type that has the label remove last. And if it can't find it, it will throw an error, so we can try this. So we are failing our test, and it's telling me no match found for element matching predicate remove last and identifiers. It tells me I have buttons, one with a label remove last and one with a label add item, which is the one that we are seeing. See here on the left, I have in the issue navigator the same information. You can also go into the run under tests. We have the same failing test. Then double tapping, and when something fails, it takes some screenshots so you can go through what happens. We have this one screenshot with these elements. So you see I have these 4 elements, and down here my button. You can also tap on this and see the button. In order to get this query, you can tap here and see I would need to look for the buttons with the remove last element. We have this label. You see the frames, the parent views. Now the problem with labels is they might change. Maybe you also want to run these tests for a different language, and then it would completely fail, because if I change this to German, there would be definitely a different label. So usually it's not recommended to use labels or visual UI elements. You want to use something more stable. And that's why this identifier here comes in. And we're going to use in code. I will go into content view. So remove last. Here I add a modifier which is accessibility identifier. So there's a lot of accessibility things, but we want to use the accessibility identifier, which is only used for testing. So this is not actually accessibility. We need to provide a string value. I'm calling this delete last item. So instead of the label, we want to use the accessibility identifier. So and in this case, I use the different label. Actually, I should have copied this over. So this identifier, which is independent of the label, I'm using to identify this here. So we can try and run this again. And the test passes. So it's always better to use these accessibility identifiers. Now then we see that once we have this button, we are tapping it. We are tapping it twice. That's why it removed the last 2 items. But I want to check my UI. So how do I know what these elements are, this text views here, the cells in the scroll view are? You see, I did get here the static text for a second. So in this case, I actually don't want to tap it, but I can say exists. So we could write a XC assert true, that this element exists, but the one that should not exist anymore is actually the third. So this would be then false. So let's try again. So we see that we do have some of these elements. Now, again, I'm relying here on string values, which might change, especially since this is rather a simple app. Maybe in some instances, if you're fetching data from the server, from staging server, this might change over time. So the text would be completely different. And then every time your test would fail, most likely in a random way. So you get these flaky tests. So I don't want to rely on these labels here that are shown. I want to again use these accessibility identifiers. So going back to content view, to the scroll view, where I show these items. So again, here I want to add an accessibility identifier because I have multiple of them. I can't just say item, then I would have 4 times the same one. I need to have something that is more unique. So for example, I can use the identifier. In this case, it's a UUID. So this is this ID, UUID, and then we can use the string value. We could also use the name. So this title here, depending on how unique this is. Now the question from the other side is I would now copy. So now they definitely need to be unique, but as you see, I have here dynamic tags that I don't really know what there will be. In my attempt to know what's on screen, I want to know that there are 4 or multiple elements that start with this item.string value. Instead of something hard-coded, I can also use a predicate. This is an NS predicate format. So I said I want to have something where the identifier contains this item dot. If you work with core data predicates, you're probably familiar with this. They just reused it here so we can do some more advanced filtering, searching. with a little bit more flexibility. So once I have this, I can go in my app, descending, matching this predicate. So what I get is the items, query elements, because we are filtering and searching here. They have some special element, which is XCUI element query. So I can then check how many items are there. You could also check what their static text is, what they're displayed. But I just want to know the count, and this should be bigger than 0. So again, this is XCT2. So we are assuming we have at least one element in this list, which I should also add here to my little error message. Expecting at least one item shown. Let's try. And I think I need to actually use launch. So launch will create a new instance, whereas activate will reuse the old one. And since I'm continuously deleting things, actually just want to make sure I have a fresh restart. That's another thing with this test. You need to make sure they are predictable and reliable. So this is passing. We can also say I'm expecting here 2. This passes. We can check to see how this differentiates from errors. So I do get here this error. Then I go to my project tests, to this test, so we can step through. So down here, you have this go forward and backward button, so I can just play. And you see the whole recording of everything. You can also just step into different places. This is especially useful if you're running not just one test where you can actually visually see it. Just want to go to a certain position of, okay, so I see it, I see visually, I remove this here. Why do I not get the proper updates? This was just because we had the wrong assertion. Xcode will only record this if it's an error. You can change this in the testing settings. Okay, going back to my little test, which is a mess. Here I wanted to show you a couple of things with searching and filtering. You saw before I untangled this into multiple functions that are a little bit more helpful. So in the future, I understand what my tests are doing. You saw here these identifiers, you always had to copy paste them over. And this is not really nice and error prone. So we want to have a reusable, nice way of storing these identifiers. So in my main app target, I create a new Swift file where I will write these UI identifiers. And here I use an enum where we can then define different static let for this add button.add, and also the delete button. Now when you look at this app, you can imagine that I only have 2 screens. I don't have many UI elements, but in a real app you have tens, 100 views with a lot of UI elements. And if I just put this in one file, it can get easily out of hand. So I'm going to add another nesting where we sort them by screen. So this is an enum. This is my add new item screen. And then I have another enum for my item list screen. Because these identifiers need to be unique, I am adding to my string values. It starts with the screen, the UI element, and then what it does. You just need to have one system so you don't fall into the trap of using the same identifiers for multiple elements. That is not good. So I have these 2 buttons and these elements. We can also add identifiers to a container. On content view, I can add this around my scroll view. So this is accessibility identifier. And what I wanted to have is this UI identifiers for my item screen. Let's say item list, which I didn't create yet. Let's go back to add this item list element. And then I had another one here for this items. In this case, I need to use the identifier I choose. It cannot just be a static property, it needs to be a function. We generate this with the identifier. So this is a static func item name string. Although it's probably better to use the identifier because that's unique and won't trouble me in the future. So we are starting again with the screen name, the item, and then the item ID. The ID is UUID string. This function I can then use here, UUID, item screen, item with my items ID. Now you might say, this is going to clutter a lot. I don't want to write this whole thingy here. And you can add a shortcut. This is the testing ID. I use the identifier item list screen.self because I want to have the static functions. So that here for this accessibility identifiers, I can just use the testing ID for these items. And the same here for the item list. I want to also do this for the delete button and the add button. Now I will also add these to the second view, which is this new item view. If you open this, we have two elements, one for the add button and the other one for the item name text field that I can use in this view. For the text field, it's the same. You can add these identifiers to whatever view you want. Again, I need to have this shortcut. I should add here private let. In this case, it's the new item screen so that I can then use the testing ID's name text field. And to the button, we have this. Okay, now that I have this accessibility identifier, how do I use them in the tests? Before I do this, I need to access these for my testing target. So the easiest way is to change the target membership here, press plus and also add my UI testing target. So now I can access this. As long as I don't use any types from my application, it's fine. I use UUID, this is okay. If I would have used my items, this is not good because then I wouldn't be able to, from my UI test target, use this function. So just use plain types, simple data here. So now I go back to my tests. I want to also do the identifiers, so I use the same shortcut with these identifiers. So above everything else, that just organize things. I want to have one item list identifiers and the new item view. I'm going to stick with the screen names so I know which one is which I can then now use. For example, here in my buttons, this is the last item, I can use item list screen delete button. So I know which identifiers I'm using. Okay, before we continue, let's organize this file. Part of writing good unit tests or tests in general is clean functions. So first, because I will launch my application always from the same initial state, I will move this code into the setup and teardown functions. So this is override func setup. I create a variable for my XCUI application. And in the setup, I am launching this. You saw we had the activate. This is different because then I don't relaunch it from the beginning. So we're not going to use that one. In the teardown, you can then set this to nil or usually it's more for real cleanup. The other argument they're usually using is here continue after failure. Once I hit a failure, one of my tests failed, I want to stop immediately and not continue with the other test. In this case, we want to stop. When we have one failure, you can also set this to true, just run everything, and then I will go through the test failures. Okay, this is the setup and teardown. So we can start each test fresh with the same state. Next, I want to go through defining what function we actually want to have. So since we are using XCTest, each function needs to start with test. I want to test that I am initially showing here items. So items shown. In each test function, I will write comments for given when then, so we have a nicer organization. Okay, so the first one would be here with these items. Then I would write another one for delete, press, remove last button, updates list. Test pressing the remove last button, update the item list. You can also add this when then, for example, test when press the remove last button, then updates the item list. Sometimes these names can be a little long. Just choose the one that makes more sense to you. The main focus is to have it in English, understandable, the intent of what the user experiences. This is the remove last button. You can also test if I remove all of them, this remove last button is disabled. So this is a test when all items removed, then remove button, remove disabled. I also can add these add main actor and these functions of throwing. So we have the proper skeleton for these test functions. And then the last test I want to write is for the add item flow. So this is the test add item, test add new item. We have 4 functions that we want to write. I will start the items shown. We already had some stuff written here that we can reuse. The one that I want to use is this predicate. I want to search how many items are shown in the UI, so I copy this. For the given, we basically just want to launch and see what's going on, so we don't also not doing any additional actions in the event clause, so I'm just going in the when. And initially we want to see at least one element larger than 0. I run this test and I see now why I get this crash. Here I did not set this to this application var, so I need to remove the let. Let's hope that now I access a proper, and we are successful, we are getting these elements. In this case I checked these elements are visible, and a lot of times you might want to add additional checks. I also want to make sure that the containing view where these items are in is also visible. So we can also check for the app scroll views, the item list exists. And once I'm here, I also should change these contains predicate. So this is the item raw ID. This is my item list screens, the item, and in this case, I don't actually want to pass here a specific identifier. I just want to have like an empty one. So I ideally would pass, say, nil, which means we need to go to this function and attach optional, so that the optional, in case it's nil, I'm not actually adding something. Actually, then here need to replace it. So this one should then be my item raw ID, and it passes. Sometimes it gives still these errors, so you can go under product, clear all test results, and then run again. And we are good. One discussion about making sure that your tests survive for a long time. I specifically use the scroll view. But what happens if I change my mind to a list in the future? This test will fail. So try not to fix your assertions to implementation details of what exact view is shown. Try to make it as general as possible, saying the container is shown. And in this case, I need to use one of these searches here. So I use a descending, matching, any, and then you can look into it and search by identifier. So this is actually this one. So now this should give me my collection. And then I can check if the collection exists. I can then further say I want to search inside this collection that these items are present. So I would rewrite these to say collection, and then it's just the same. So inside, not just generally the app I want to search, now in this container, give me the items. So run again, and we passed. So now I made this a lot more stable by adding more assertions. So I know, okay, it's not this, if it fails in the future. I do have my collection. That's why you always add information to this assertion so you know what might be the problem. You can see this as breadcrumbs to know what went wrong. Which code should you look at? Should see the container, scroll view with the items. So this is more a container as the first assertion, and then I want to see something in this container with these items. I specifically did not fix myself to a certain number of items because now I use my dummy data. But maybe in the future I change this to 10, or if I use a list with lazy loading, then this is definitely even more flaky. This was the first little test, and we continue with removing these items. So in this case, I press on this remove last button. So again, the given is just in the standard. And in this case, I want to find the remove last button, which we already did here by asking the app buttons for this one and then tapping it. So we get the last button and then we're tapping it. If it can't find this button, this is already going to give me an error here. And then I need to check how many items are there. So I would need to do this whole stuff again. Only in this case, we would need to check the difference in the count. We are starting by checking the precondition. What are the current number of items in this list? We're getting the identifiers, the predicate, and the items. And I also need to have the collection in here. In this case, I only want to get the count. So this is the initial count. Let's add a little exertion. So my initial count should be bigger than 0, otherwise it doesn't make sense. Then we are tapping on this button. I can also write this shorter, but because I don't actually need it, look for a button with this identifier and tap it. And then we want to check that the UI updates and we have one less item. So I need to again count my items. So this is the final item count. I use the same predicate on the same collection. And now the assertion is that my initial count -1 is the one that I have here. So my initial count -1, actually I will use XCTUITest equal. So is equal to my final count, and then I expected that item count decreased by 1. So let's run this also. We should see that the last item disappears, and it does, and this test passes. You can also check if your test makes sense by stress testing your production code, your app code, for example, in my content view. When would this functionally break? If, for example, I accidentally forget here to actually call this viewModel function. So if you uncomment this, now we can still press on this button, but UI should not update. So go back and run this test again. It taps, but it fails exactly at the line we would expect. We get XCTUITest failed. We expected 3, but we found 4 items, which means we didn't actually decrease this. Then going to the project tests, you see here in my little replay, it did press this button with this indicator, but my UI didn't update. Then in the future, hopefully tells me that I did something. But you can also write tests. There's one problem with what people complain about UI tests, it is hard to know where in your code things break. In this case, the problem is that we actually didn't call the function when pressing this button. By using this replay, we can see we actually press this button, but nothing happens. Until this point, it's fine. You can add more detailed tests, supporting tests, where you would, for example, want to test if the user presses this button, is this function called. This you cannot do easily with XCUITests, as you see. It's a black box, you can't really see inside. There's other ways, but this is another topic. But definitely when you're using XCUITests, use this reply functionality here, as you see. It's quite convenient. I go back into my content view and call this function again. Then we step through what other things could go wrong. In my delete last function, I could also simply not call this function and this test would fail. But let's just continue and run this again. It should now pass. Okay, great, we have success. Then the next one is I need to remove all items to see this button, to test that this button is disabled. Now, because we are launching from the beginning, I need to press this button multiple times, which means I need to know how many items I have. So we need to have this initial stuff. So I copy this. There's ways of reusing some of this code, but I don't want to go there yet. So again, we are fetching this, we are checking, we know how many items there are there. I'm pressing this delete button multiple times. So in this case, it is more useful to have this code. So, and I'm moving this one into the given. So we are expecting that this button is there. Then we're expecting this should happen. So we are now tapping it, the number of times of elements we have in the list. Then we want to check if the remove last button is enabled. So this should be false with a nice descriptive info. Delete button should be disabled. Try this. So removing all of them to make this test a little bit more stable. First here I assumed I have something to delete, but I also want to add an XCTUITest assert that we are starting off enabled. This is a breadcrumb for future me, that I know this is giving me the right information. So this starts off as true. Should delete button should be enabled initially. So for example, if I make the mistake of here for my remove last button, instead of calling this property from the view model, I set this to true all the time. Now I can't ever press this button. If we test this function, it stops at the precondition and tells me this failed. Then if we go into tests, test function, you see here the screenshot, and indeed my button looks disabled. So now I know I did something wrong in my view, and here I'm just going to undo this. Because this is enabled, connected to the items, I am also adding here another check to fetch the items. So I know the delete button, why is the delete button not disabled? Because it's connected to the items. I should first check if the items are updated correctly. So again, I am getting the final count and I'm expecting this to be 0. Expected that no items, no more remaining items. Okay, we try this again. Deleting all of them, and this works. Try to write this function as descriptive as possible. Add assertions. Spend quite a bit of time on assertions. Stress testing a little bit on your UI so that we see more information. You can then see in your tests here which one broke and where did they break and what was the root cause. Now the last test is testing adding new items. So what do I actually want to do in this case? I want to press here on this add item button. Did I have this before? I get the button from the Add button tab. Then I tap in this text field. Or maybe we just use the record functionality. So I tap into this function, I press record, I press add item. We see this is pressed. I tap into this text field, test. It did not actually add anything in the test field. It did not record it properly. But we see this test element. This is what we need to check. Use the static ones. Okay, I stop. This gives me enough information of what I should do. I need to first tap on add item. This is the button that we just had. Then I need to find this text field. The identifier here was in my no item screen text field. So this is text field. Text field dot tab. Then we can say text field dot type text. So let's say we have test. Then I want to find another button, and this time is the apps button. This is this add button in this screen. I'm using again my shorthand for add button. I need to look into my list and check how many items are there. This is again, as in this case, I'm expecting a new item. Basically, I'm expecting that the list increased by 1. So we would need to do again this whole searching of the item row, predicate, and then this count. Because we're increasing by 1, I do a pre-check with the initial count. My initial count is higher than 0. Just need to have an initial count. So we have something. Then the event clause is what steps do we go through. I press add item. I show this. I press this text field. I enter a text and I press add item. So then in the then clause, I will need to count this again. So this is my final item count and the assertion equal. So I'm expecting that my initial count plus 1 is equal to my final count. Expected to have 1 more item in the list. Pressing add, ending the test, and then you see this element is there. The thing is, because I can't easily step ahead, I sometimes need to go through the whole flows, so you end up testing multiple steps in between. The good thing is it will fail at some point. For example, if it doesn't find a text field here, I'm just going to break this and test this again. If it already doesn't find a certain element, it will stop there, so you know which elements you need to look into. So it failed. Going into my little test. So, play. And here it's when it's breaking because it doesn't find the right UI element. So, here you see it's trying to find something. If I tap on this item, it has this identifier. I think this is the ones underneath. I probably need to go a little bit. So it's this one. Yes, this is this text field that it couldn't find. So you see this is the identifier, and it also tells you which one it had and what elements are actually present. The whole point was, even if you go through a whole flow, a lot of the times it will tell you where the problem was, what it couldn't find. So you just go through this process and see what was there and what it couldn't find. This test works fine as it is, but there's another problem with XCUITests, and that they're flaky, which means sometimes they fail randomly. This is usually caused by timing issues. In my case, this sheet comes up. We are relying here that it waits enough time for this sheet to be present and then looks for it. If it does the check too early, this view is not there. So if you have situations where certain elements might appear a little bit delayed, maybe after an async call, a network request, it's a good idea to add waits in between. For example, I might want to wait for this text field to appear. So before I actually interact with this, I say assert text field exists or wait for existence with timeout. This also has wait for to equal. So if you have more sophisticated paths, for example, you might want to wait for the new element to appear with this predicate. In this case, it's easier because we have wait for existence, timeout of 1. Now, this is the maximum time it will wait. If it exceeds this, then the test failed. We are adding this to make our test a little bit more stable in the future. This is one of the most frustrating things with tests. The app actually works, but your tests constantly fail in a random order. So waiting for existence is a quite good thing. We can also just do this opposite here. When I'm pressing my add button, I'm expecting that this overlay, this sheet is disappearing. So I can also say text field wait for non-existence. In this case, what I'm actually testing here, expected that add button closes sheet. If you don't want to do this with a certain view, we could also use the accessibility identifier around the sheet. So here I have identifiers to this specific views, this text field and button, but we can also add one that we identify the whole screen, the sheet, this view. So I think I did not add anything for this. We would say sheet, and then I would add this here as a new case for my new sheet dot shown. You can decide what's more descriptive for you. So in this case, I am checking that my sheet is closed. So this is a sheet view. When I press this add button, I get this sheet and I add an XCT assert to say sheet wait for existence timeout with the explanation expected to show new item sheet. So we also understand the intent of all these different buttons. In this case, when I press this button, I expect this sheet to open. In this case, I can then remove the other wait for existence, because this will fail then here, this button. It's up to you how many assertions you want to have. As long as it helps you to understand your code, what's supposed to happen when certain actions are executed. So in this case, it's these two belong together. When I press this button, I expect this sheet to show. Then I am working here with this text view, and I press here this button. My expectation is, the final one is first, I don't have this sheet anymore. So we are going to actually use this sheet with the expectation that this button closes this sheet. Then we are calculating the new items, and we are expecting that we have one more item in the list. We're running, we're adding something. So this test failed because I can't find the text field. I go to the project navigator, tests, I double tap on my failed test, and we are having a look at the recording. It opens the app, it presses on the add item button, that's good. And the last part where it's the little red diamond is, it checks, I go there to see this overlay. I see also what's behind it, no? Let's check the button. I have the sheet shown. This is actually supposed to be the button. And if I tap on this text field, it's again this sheet shown. So it seems I have a wrong identifier. Now if we go to the new item view, this accessibility identifier basically overrides these two. I don't want this. With the scroll view it worked. So in this case you need to use the accessibility elements, children, contain. You can also hide the children. This is what we want to have. So I can get the container and then the children of this, or combine where it's merged. Okay, contain is fine. I go back to my little test. It finds the text field this time, and we're having a successful test. This is really nice. So we finished now all of these tests. I can remove these initial function. I did only currently execute one of these tests at a time, but I want to just once do everything. So in the testing navigator, I press on the top to run all the tests, which includes my unit tests. I didn't touch this code, so they should still pass. And actually opened another simulator for my launch tests here. This is a little bit different. So it actually tests all different orientations. Okay, we successfully went through all of my tests, my UI tests and my unit tests. We now go again to the tests to have a look. So maybe I just hide the launch ones because they're not the interesting ones. So they're ordered alphabetically or in a random order. Now on the top, I have my unit tests, and on the right you see the duration. These unit tests, because I only run very small chunks of code, they're really fast, so they're like 1/1000th of a second. These run nicely in parallel, so there's no problem adding hundreds of them usually. Whereas my UI tests, you see here, one of them is 19 seconds, 15 seconds, 6 and 4. That makes them really slow. This is probably one of the main complaints for XCUITests. They are slow and flaky. They sometimes fail. Now you can make these a little bit faster by disabling the animations. I only want to disable these animations for my tests, and for this we are using a launch argument. So far, I always launch my application from the very beginning, but in some cases you want to have different test situations for your app. A new feature, you want to test with the staging server instead of the production server. You want to use mock data instead of the server data. How do we communicate this from our tests? We can use the app, launch arguments and environments. The difference is one of them is just string values and the other is key value pairs. So in this case, we could launch argument is more for, let's say, the base URL. This is a string value where you would, for example, have my app.v2 for staging 2 as the base URL. So this one is only then used for this test. Or you can say launch argument for UI test, or something like this is the one that I want to use. So if I have this launch argument, then I'm going to change my app and disable these animations. Okay, this is then from the side of my application, of my tests. Unfortunately, you need to touch your production code to change this, to configure this. Yeah, which is always a little bit not so nice to pollute your production code. But the whole discussion of how to integrate this with the app is anyway more complex. Let's use this small example with these animations. You can use process info.processinfo for the environment. So this is the key. This is the dictionary, but I actually want to check the arguments. So if I have something for, what did we call it? No animations. Arguments contains this value. So if in my process information, the arguments, this is coming from the test, then has this key, then I want to disable animations, and we can use a UI set animations to false. This should help to reduce the animations. So let's go and run our whole UI tests again. Now the UI should be faster because, for example, when the sheet comes up, it would be instantly up and not slide in slowly and not slide out slowly. You see this sheet came instantly up and then dismissed instantly. So this helps a little bit with speeding things up. And we can have a look at the difference. So this test was the last one I did. With the animations enabled, I have 9, 4, 5 and 4 seconds, which was around total of 23 seconds. And this last one here with this enabled is 1 second faster. This is because it's mostly saving me time for this sheet. So the animation of this sheet coming in is then disabled. It's just a little bit faster, but it's still quite long. Another thing you can do is, right now, all of these tests run in one simulator with this one app. You can create different classes here. So I had here, for example, I can extract the delete functions. I create a new file from template, XCUI, XCTUITest. This is delete items tests. Just below, I am using the same setups, and I'm removing the placeholders, the auto-generated code. I move the two functions where I remove just one element and then all, and move them over to my delete functions. Now I have two tests running in this class and two in this. I go to my testing navigator and press just the UI testing target. And now I need to find out all my simulators. So now it has two simulators. So this is both iPhone 16 but different clones. One of them is running the add functions, and the other one the delete, because I run them in parallel. The total thing only took me 14.5 seconds. You can distribute this on different simulators to speed it up. There is also something in the XCTest plan under options, parallelisation. If you don't see this file, go to app, schema, under test. If you don't have a test plan, then you need to go in here and it will generate one for you. This changed a little bit from 15 to 16. The good thing about XCTest plan is now you can, for example, use the shortcut Command R to run all of them. I can disable my whole UI testing functions. Command R is for building the app, and Command U is just the testing. In this case, I'm only testing here my unit tests. They are passing. The other one are grayed out because I disabled this in this test plan. You can also enable the UI test and then maybe just disable a couple of these functions. So during your development process, you don't have to wait for all of them all the time. It's a little bit of a tricky situation because obviously you want to run them as often as possible to catch problems early on. But if you always have to wait a couple of minutes, this is a problem. Another way of dealing with this is that instead of having a lot of small tests, you end up writing longer tests, like the whole flow, for example, the whole onboarding flow, and then the purchasing flow. So you go through all of these steps, because as you saw here, I always start from the beginning. You can just use these launch arguments to skip ahead. For example, if you have one with a deep link, you would add this deep link, catch this in your app, and then use the information from this deep link to navigate programmatically to the view that you want to skip onboarding. From the point of view of the test, this is easy, but how you integrate this in your application without cluttering and messing up your code base is a whole nother discussion. I will link some information in the detail box. Now, as you saw, the big problems with this UI test is they're slow and sometimes brittle, flimsy key. I have this problem with communication for what I want to actually test. This is the reason why most people end up not testing too much with XCUITest, maybe just the most important flows, one happy path. Before you go too deep into XCUITest, because they're really useful, you get all the user interactions. I didn't even talk about gestures. You can test gestures, scrolling, swiping. So it's pretty great. But for writing a lot of tests, smaller tests that run quickly, it's not ideal. There have been alternative approaches for UI testing for SwiftUI. And it's a good idea. And I would recommend to have a look at them to see where they fit into for certain cases you want to test. In particular, there is snapshot testing, which is good for regression tests. If you have a feature that is rather stable, it will take screenshots and compare them in the future. They're quite limited because they fail often. Then we have View Inspector. This is then using introspect to look into the underneaths in your SwiftUI views. The problem is because it uses some quarter internals, it breaks often, and it's also not super reliable for everything. It definitely has its place when you want to check certain visual elements. The third approach I will introduce in the next video, where I will show you a framework I built for testing that works similar to XCUITest but more unit test style, where you can get very quick focused tests and control how the test environment works. So go ahead and have a look at this now. Thank you for watching. Until next time, happy coding.